Okay, back again. This is rationalizing a denominator. You're not allowed to have i's or imaginary numbers in the denominator, okay, of any fraction. All right, so I'm going to teach you two ways how to rationalize these denominators, and it just depends on how complicated your denominators actually are for you to be able to do this, okay? So let's start with one like this. Let's say that you're given the fraction 5 plus 4i over 7i. Okay. All right. When there's a monomial on the bottom, meaning some number in I or just I. Okay. What you want to do is multiply by. You always just want to multiply by. I'm going to call it opposite I. Going to multiply by opposite I. Okay. Here's what that's going to do for you. Number one, it's going to cancel out the I on the bottom of your denominator, which is your goal right now. Number two, it's going to make your denominator become a positive whole number, which anytime you can make something positive, you're a lot better off than if you accidentally make it negative. It just leads to mistakes, okay? So right now I have 7i. It's positive. So I'm going to multiply by opposite I, or negative I, on the bottom and also on the top. Opposite. It was a positive 7i, so I'm multiplying by negative I, okay? Now, here's going to be my answer. Let's work on the bottom. 7i times negative I. 7 times negative 1, the negative counts as a negative 1, is negative 7. I times I is negative 1. Negative 7 times negative 1 is positive 7. So look what I did. I turned it into a positive number. That's helpful. And the I is gone, okay? Now I'm just going to distribute through to the top. Negative I times 5 is negative 5i. That's pretty easy, okay? Now I've got negative I times 4i. Again, negative 1, the negative sign counts as a negative 1, times 4 is negative 4. I times I is negative 1, so that's a positive 4, and that one's done. Okay, let me show you another one. Just I want to reiterate on this idea here of opposite I. Okay, so I guess I'm going to have to erase this idea of opposite I. So what if I had, let's say I had 6 minus 3i, and that's all over negative 2i. Okay, I want to multiply by opposite I. On the bottom is a negative 2i. They are negative. So the opposite of that would be a positive I. I'm going to multiply by positive I this time on top and bottom. I need my parentheses up here so I remember to distribute. Negative 2i times I. I've got my negative 2. I times I is negative 1. Negative 2 times negative 1 is positive 2. I've accomplished my goal on the bottom. I times 6 is 6i. Negative 3i times I. Negative 3 has nothing to be combined with, so it stays negative 3. I times I is negative 1, so that's a positive 3. So that's plus 3, and that would be done. Okay, let's talk about what to do when it's a little more complicated. Okay, so a little more complicated goes like this. It's when it's a complex number, a binomial on the bottom. So I got negative 1 plus 5i over 3 minus 2i. Okay, what you always want to multiply by here is the vocab word. Now, since it's a binomial, you multiply by the conjugate. The conjugate means all you do is you change the plus minus sign that's in the middle. It doesn't matter what anything else is. All you're focused on is this plus minus sign in the middle. If you want to get rid of these i's on the bottom, then you multiply by its conjugate, which the conjugate of 3 minus 2i is 3 plus 2i on top and bottom. Now, you're about to see the magic here of conjugates. What conjugates do is make all of the nasty stuff cancel, okay? So watch this. 3 times 3 is 9. 3 times positive 2i is positive 6i. Negative 2i times 3 is negative 6i. Negative 2i times 2i is negative 4 times negative 1 is positive 4. Look what happens to my I terms when I multiply by the conjugate. 6i minus 6i is gone. So I'm just left with 9 plus 4, which is 13. I've just turned my denominator into a whole number, the number 13, which is, again, my goal, to get the i's off the bottom. Now I'm just going to FOIL the top. Negative 1 times 3 is negative 3. Negative 1 times 2i is negative 2i. 5i times 3 is plus 15i. 5i times 2i, put it in your calculator or whatever, is negative 10. So when I combine like terms, I get negative 13 plus 13i. When I reduce this, I can divide. I have to have all three of these numbers have to be divisible by the same thing. Not just two of them, not just one of them, all three of them. They're all divisible by 13. So I can reduce that down to negative 1 plus I all over 1. There's no real reason to write all over 1, right? Okay. Let's do one more. Oh no, I don't have enough room. Now I do. Okay, let's try one more. Again, multiplying by the conjugate. Multiplying by the conjugate. Let's try this. I'm just making one up off the top of my head. 2 plus 3i. I want that to be over negative 4 plus 3i. The conjugate only focuses on the plus minus sign in the middle. So the conjugate of negative 4 plus 3i is negative 4 minus 3i. Notice that I didn't change the sign of the negative 4. I'm only changing the sign of the thing, that the plus minus sign that's in the middle. And I multiply the top and bottom by the conjugate of the denominator. Okay, here we go. Negative 4 times negative 4 is 16. Negative 4 times negative 3i is plus 12i. 3i times negative 4i is minus 12i. 3i times negative 3i, put it in your calculator if you need to, is positive 9. Again, notice that my I terms cancel. This is the magic of conjugates. I'm on the bottom left with the number 25. 16 plus 9 is 25. On the top, I'm now going to FOIL these together. 2 times negative 4 is negative 8. 2 times negative 3i is minus 6i. 3i times negative 4 is minus 12i. 3i times negative 3i, put it in your calculator if you need to, is positive 9. Negative 8 plus 9 is 1, minus 18i. I'll put this in the numerator. Okay, that is rationalizing your denominator, whether it's a monomial or a binomial. See you in class tomorrow. I'm sure you'll have questions.